Okay, welcome again. Congratulations to those of you who have been with us for the whole day. If you are still breathing, you survived Unfold, and so you are in the badge. For those of you who just joined the Unfold, so thank you for being with us. I'm gonna quickly explain what we are about to do. So with this awesome panelists, we're gonna explore the nuances of designing for complexity, and we're gonna follow this format. So each one of them is gonna use 20 minutes for a conversation starter. They will be free to contribute to each one, let's say, presentation, let's say so, even if I don't like really the word in this case. And then we'll open up the stage to the audience for your questions. So please be sure to have very challenging questions for my guests here, because our aim is to have some fun, entertaining, and also insightful discussion. What else? So I'm going to also do a round of introduction, but in this case, I have to read because my memory is so weak at this point, of the day. So on stage, we're going to have Allison Rowe, which is a strategic designer, design leader with over a decade of experience guiding design, products, and innovation teams. Then we're going to have Matt Webb. He has been collaborating with some of the world's largest firms on design-led product invention using new technology for over 20 years. He's also the co-founder and CEO of the design studio Berg. He's also the owner of the product boutique Acts Not Facts, and he said that this morning is the only one person, there is part of this boutique at this point, so we know that. And he's also the designer behind the Poem One. If you don't know Poem One, please start Googling it. It is a very interesting, product. You'll find information on a Kickstarter campaign is just, let's say, closed. Then we'll have Silvio Lorusso, which is an assistant professor and co-director of the Center for Other Worlds at Lusófona University, Lisbon, and also tutor at the Information Design Department of Design Academy Eindhoven, and also is the author of What Design Can't Do, Essays on Design and Disillusion, published in 2023 for Set Margins. Last one. And then we're going to have also with us Georgina Voss. She's an associate professor at London College of Communication. She's also an artist, and she's also the author of Systems Ultra, Making Sense of Technology in a Complex World, released for Verso Books. That's all on my side. So Allison, the stage is yours. You start.
Hi, everyone. So I'm going to give us a little signposting for where we're going, also because I'm not super used to doing talks with very few visuals, and we just have to kind of stream of consciousness here. So we'll give it a try. But I was thinking about starting today with talking around decentralization as an antidote to complexity, and also thinking about complexity in the realm of natural ecosystems. So we had a lot of conversation today, and a lot of the examples that we have on the walls here and the other exhibitions are all about technology. And I thought it would be kind of nice to bring us back a little bit to nature and see what we can learn and think about from the world around us. So I was thinking a bit about complexity as, let's say, an organizational concept, I guess, with this structural and kind of spatial component and identity. And so not in the abstract way. We hear things like, okay, we live in the VUCA world, which is, volatile and uncertain and complex, but what does that mean, right? It doesn't have a feeling to it. So I'm thinking, and I guess I'm a tangible person, so I'm thinking about complexity as entanglement. It has this physical component, or thinking about it as dissonance with a sense of, an oral or an audio component, or as this kind of unfathomable scale, so a visual element to it. And thinking of something that kind of has mass and influence and consequences. And so I guess my first invitation there is to is not to embrace complexity, right? That's often the first thing that we hear in our design work. We say, okay, this is a very complicated world we live in. We just have to embrace complexity and navigate our way through it. And I think that there's something there about acceptance. It's something there around we like to jump to solutions. And I am inviting everyone to instead sit a little bit and maybe we try wallowing a bit in the complexity instead. And so think of it as something that we kind of want to swim in, and instead of something that we would embrace and kind of be able to put our arms around, because embracing inevitably means simplification. It means kind of reducing the elements. So what if instead we start to swim through this network? And what I have here, does anyone know about the Tokyo slime mold experiment? I see a few people nodding. This is like a very old example from back in 2010, when some researchers in Tokyo took some slime mold and they tried mimicking so they put food sources at the different points of the main subway stations in Tokyo, and then let loose this slime mold into this empty petri dish, and watched as it started to form networks between those food sources and started connecting them. And this is a not particularly intelligent organism, right? But we could see that it was able to make these connections that were super, super efficient, and that were actually very, very similar to the final designs of the Tokyo subway system, which they had taken loads of very, very smart urban planners and designers to come up with this thing, and instead you could feed it to a mold and kind of come out with something, give or take, as good. And so fast forward more recently, I think this was in the past 2 years, some researchers at the University of Toronto then rehashed that experiment, but created a computer model instead of a virtual slime mold. And so first they had to test and see if their virtual slime mold was as good as the real slime mold. So that was like kind of their first test. And then they started using it to simulate planning. And so could they do the equivalent of this kind of experiment on the Canadian version of Disneyland? So they put in, instead of the subway systems, they put in the roller coasters and the food carts, and watched as this thing created the optimal pathways between those two things. And found that it was, they were able to kind of reduce the time, reduce the disruptances between, as people were moving between roller coasters and food. And so I think this is a really example, I guess, of course, there's this side of biomimicry and kind of nature-inspired design, but also this mental image that I have of this idea of kind of wallowing complexity, in the sense that the slime mold is not embracing anything, right? It's not like bringing its holistic thinking and its best analytical ideas to the game. It's kind of sensing and moving and working on one piece at a time, and kind of thinking and acting simultaneously, and even those two things being kind of one and the same. And so if I then, I guess, expand a little bit on this idea and move towards this power of decentralization, which I think is super interesting, and I guess specifically the need for more place-based services and initiatives. And so what you see here, so my family is from Hawaii in the United States. So it's a string of these 8 islands just popped out of the Pacific Ocean, formed millions and millions of years ago. And they were inhabited by people from Polynesia and Tahiti that came in canoes and brought a whole bunch of plants from that part of the world and started making settlements in the coasts. And the thing that's interesting here is they built this ahupua'a system, which was not just a mode of farming, but also a kind of socioeconomic and climate and geologic way of subdividing the land. And so on one level, it's this agriculture and this food system, but also on the other level, it's a community organizing principle. And so you essentially have these strips moving from the mountains all the way to the seaside. with the types of agriculture specialized to each location. So depending on the altitude or the rain or the amount of water and the soil type, what is best suited to grow in each of those locations, including, all the way down to the ocean itself and creating fish ponds and things like that. And it kind of created this really beautiful cross section of resources that was designed to meet that, that exact population that was living there. And with the different people that, again, lived in these different strata of land would then be specialized in that kind of particular kind of farming. And I bring this up as an example to contrast that with what we do today. So again, using Hawaii as an example, right now, 90% of the food there is imported. And so they have about 2 weeks of food available at any given time. And so if there's a disruption in the global supply chain, like for instance, a COVID pandemic, that's a really big issue, right, for food security. But if, according to a lot of the research, in the past, there was an estimate that only about 6% of the land was farmed in this way, but it produced enough food to feed over 1 million native Hawaiians. And that is almost as many people as live on the islands today. And so if you contrast that and you say, oh, okay, we got this like ancient agricultural technique that was able to provide for the same amount of modern residents, when today we can grow ridiculous amounts of pineapple. That's all getting exported. Nobody gets to eat that. And can't be self-sufficient. And so contrasting those two things. And I think this isn't just, a call to revive these ancient techniques. So of course, we talk a lot about these kinds of ideas, but it's also a way, I think, to recognize the value of what I'd look at as, say, a decentralized system of production. And so each region being super good at what they do and also what is adapted to that place. So it's being super place specific. And then all of those regions brought into a collective. And so this is the model where you say, okay, how do we have these nodes that are kind of optimized and independent and able to fend for themselves, but also in a broader way, able to create a balanced diet and, a kind of a full nutritional palette with this library of plants that they have. And so maybe you can't replicate something like this exactly in everywhere, but there's an interesting thing there around saying, okay, this is its own form of a complex system, but is, kind of intertwined in a completely different way than when you think of our traditional complexities, I guess, in the systems that we have today in our modern systems. So I'll zoom out again one more level and just think about, okay, what if we applied this on an even bigger scale? And so this is a map produced by an organization called One Earth, and they pose the question of if nature were to draw a map of the world, what would it look like? And so we usually look at maps and we see all of these, political boundaries and national boundaries. And instead, they've created this framework based on the identification of 185 bioregions. So those are subdivisions of biomes, things like deserts and broadleaf forests and shrublands, things like this. And they've subdivided those even more by laying across, okay, where are the mountains and where are the rivers and where are the waterways, and how can we look at these places as these sort of individual microcosms of nature and their unique properties. And so imagine, something like this Hawaiian agricultural system, but perfectly crafted to each one of these locations, with their own methods of production, right? The indigenous methods that people had at one point and have lost along the way, but also overlaying the culture and the community organizing principles and all of those levels to make a really beautiful amalgamation of how we can organize ourselves and also provide for ourselves in a much more self-sufficient way. And in this way, kind of replacing one version of complexity, which is that global scale, to a different kind of complexity where it's really through, say, symbiosis and exchange between these different regions in a way that is, how can we exchange the knowledge instead of exchanging our products? So again, using this food analogy, how can we exchange, the know-how of how to grow in one biome that's on one part of the world that's very similar to one in another part of the world, and exchange that knowledge instead of flying our avocados from, literally from one place to another. So in this way, we can start to see the connections between these places, the different nodes that we might be creating, and the kind of the flow of not just resources, but the flow of knowledge between them. And then I'll just bring the scale back down again to kind of close things out, because I think what is interesting around what keeps, what you could say a complex but decentralized system running isn't a centralized authority or a single operating system, but thinking about more of a collective intelligence. And so bees have been on my mind recently because I just became a bee mom. So I live in Tuscany, and we just put this hollowed out log in our yard and have a swarm of bees that have now inhabited in it. So I go there. They've been there about 2 weeks. So everyone cross your fingers that they're happy with their new home and they're gonna hang out for a while. But so I've been thinking a bit about bees and how they kind of organize themselves. I think we're probably all kind of familiar with this idea of swarm intelligence that things like bee colonies or ant colonies have. And so it's a way of talking about a more sophisticated, let's say, collective behavior. And so a way that goes beyond the capacity of any of the individuals and what they can do, and create more of a, I guess, a higher level of organization amongst the individuals in the group. And I think that there's one of the things that I find fascinating here is that we often think of bees as okay, these like mindless drones that just hustle around and gather pollen and don't have very much agency. And when you look at instead how they're kind of structured and their roles and responsibilities and how that changes over time, there's super, super interesting dynamics that have to do with like the pheromones. And so if the queen like puts out these pheromones that keeps everybody liking each other. So there's specific like, colony happiness pheromones that she puts out where everybody feels like, oh, very close and attached to each other. And then maybe later on, as the queen starts getting a little bit older, she produces less of those pheromones. And so some of the other bees are kind of sniffing and they're like, I don't really feel attached to my fellow bees anymore. Maybe I should go out looking for a new home. And they start scouting for a new place so that part of the colony can move off and live somewhere else. And so they start looking around and to find a new home. But then when they find something, they have to come back again and then convince the other bees and also the queen to then move to this new place. So they've got this elaborate kind of dance, and they make a new kind of the little egg holder that's specific for a new queen. And so it's this really interesting back and forth in the communication where there isn't one decision maker, but there also isn't a kind of a single way of communicating. So there's this interesting kind of collective understanding that starts to disseminate between how things smell and how everybody's dancing and how they organize themselves, where some decisions start emerging out of that. And so this process of emergence is where that intelligence then comes from in how they then begin to move and make decisions and somehow manage to live in sync with each other. So I think that the maybe takeaway from that one that I think is really interesting around, if we think about what is our role in this decentralized system, there's also something to me which I think is interesting around if you look at the bees and their multiple identities and how they kind of take different jobs over time. How can we also start to think about that multiplicity, or the multiple potentials that we have? Can we play with them a little bit more? So play with our identities as a way of also then playing with these potential connections that we can have, being like that slime mold, kind of moving through space, finding connections and saying, okay, let me test out the waters over here. Let me see what this has to offer. Kind of oozing in another direction, checking that out. And so beginning to live in this more, let's say, decentralized way, distributed way, where we know our environments a lot better. We're much more connected with what we need in our place, but also have the ability to then find new connections and new methods of kind of mutual exchange with other locations. So if I think about, I guess my wrap up to all of that is around, okay, how are we not embracing complexity, but actually just wallowing in it, as I said, looking for those nodes and connections? Can we deal with it in a more decentralized way? Use our collective intelligence to have a bit more of a place-based understanding, but also this collective decision-making about what we want to do and how we want to organize ourselves. And then start to play with these new connections, these potential identities that we can have, and kind of use that as a different way of imagining what our futures could be. Thank you.
Okay. Thank you for that. That was brilliant. I'm going to change gear a little bit and go from nature straight into technology. So sorry, not sorry, kind of, interesting difference as well, I think. So I'm Matt Webb. I'm from London. I have a micro studio there called Acts Not Facts, which I work with software and hardware to do product invention for large tech companies and for startups. And what I mean by product invention is they usually have some kind of new technology, which is complicated and they don't know what to do with it. And then the job is to figure out what to do. What are the kind of opportunities? Now, over the last kind of year, that's basically meant generative AI. So what I thought I would do is talk a little bit about what I've been learning with Gen AI and two particular opportunities that I think that designers and artists could be playing in more. And then at the end, come back round to what kind of lessons are there then for engaging with complexity, and then what might that teach us? So yeah, like three things. One is I want to introduce Gen AI and how I see it. Second is these kind of opportunity spaces. And the third is what can that teach us for engaging with complexity? I guess the first thing is on how I am seeing AI at the moment is it's a really interesting material, but it's not magical. I think there are a lot of people who have a vested interest in talking about this as a magical technology that will either solve everything or end the world. And both of those to me are people who have a goal of making us think that it is somehow kind of like the new gold, or is kind of like unapproachable because they want to protect their own positions in the industry. There's always, when somebody says there's an existential risk, a little bit where they're bragging. Oh, I invented this thing, it might end the world. You might have heard of it, right? We have to kind of start thinking about Gen AI as just another material. And as designers, we all work with different kinds of materials. So what is it about this one that makes it different? One of the projects I've been working on recently is Poem 1, which you mentioned at the beginning. Thank you. It's a clock, a physical clock that lives in my house. It composes a new rhyming couplet, a new poem every single minute to tell the time. So every minute of every day, there is a new poem. They're often not very good, which tells you exactly what time it is, mostly. Sometimes it lies about the time in order to make the poem work. Sometimes it makes up words to tell the time. And it's interesting living with this device, which composes 500,000 poems a year, because it demystifies what AI is to me. It's good at some things. It's not good at others. It is very samey in some places. It's weird and quirky and has its own kind of grain in others. And it's that kind of encounter with the new technology which has kind of made it possible for me to work with it with my hands. So out of this time of working with my own projects and with clients, what are these kind of two opportunities? One is, and I'll show a picture of this in a minute. One is we need to think, I think, about what is the future of generative AI. I think most of it, our encounter with it is about generating images like Midjourney, or generating text with ChatGPT, maybe to have a conversation with it. And the narrative we have with this is that they will improve month by month, year on year. And there is a kind of a Moore's law thing going on here, right? Like Moore's law, the idea that computers double in power every 18 months. And that's very much what AI feels like to me. It was like a 10-year leap forward. A project that used to take me 4 days now takes me about 20 minutes and $30 on my credit card. So that 4 days down to 20 minutes is a 10-year leap forward. But the thing about Moore's law is it doesn't just mean that computers or AI gets twice as good every 18 months. It cuts the other direction as well. So instead of saying these things get twice as good, twice as big, twice as powerful every 18 months, we can say they get half as expensive, or they get half as big, or they get twice as ubiquitous. So looking forward over 10 years, we might, instead of saying, oh, we'll have these superhuman intelligences we hang out with, we might say that we have ubiquitous intelligence. We might say that we have something which is dog level or human level intelligence in a grain of dust, or in every light switch, or in every Hoover. And what does that mean? What happens when intelligence becomes just too cheap to meter, almost kind of environmental? There's a project from, I think I've lost the, no, I haven't lost the reference at the beginning of this. There's a project from 1980, which was from the media room at MIT, the predecessor to the media lab, called Put That There. And it was an experiment about a multimodal interface, which just blows the current kind of previous work of voice assistants over the last few years completely away. The idea is that your room, your interface, can look at you and see your gestures as well as your voice. So when you're pointing around your room, you might say, put that there. And it understands what you mean, pointing that there. It understands the indirect reference of there to talk about something you were referring at previously. And these kind of interfaces are fascinating and powerful and natural, but they have been impossible so far. Environmental AI, not generative AI, but intelligence which is embedded in sensors which understand pointing or glancing, make all of this possible. It's also interesting to look at electricity consumption. It will be possible, it is possible already, to run a microphone on small amounts of electricity, well, about the same kind of energy budget as you can pick up by energy harvesting. So no battery, no wired electricity, just picking energy out of the air off ambient radio signals, enough to kind of run a microphone, and potentially a tiny intelligent neural network. So I think the first opportunity to dig into is what happens when we have environmental intelligence. What happens when our environments understand us? And what do we do? What are the second order effects to do with, how does that feel? Does this feel like pervasive surveillance, or are there ways of kind of putting this in our control? So that's kind of like opportunity number one that I find particularly interesting. The second that I find interesting is that we can use large language models and artificial intelligence to give us new senses, the ability to see things that were previously not visible to the eye. So the analogy I have here is to the microscope, which lets us see bacteria, or to the camera, which let us see the movement of horse's hoof, and to see how they actually galloped. Here, I think AI gives us an interesting insight into language. So this is an analogy, this wasn't actually produced by AI. This took about 3 months, this particular piece of work. What it is, it's a graph of literature, the average length of time described in 250 words of novels over the last 300 years. So if you go back to 1719 with Gulliver's Travels, 250 words would describe a week. If we look more recently in about 1990, Midnight's Children, 250 words would describe 6 hours. Over the last centuries, literature has becoming fast. It's becoming much more immediate. 250 words are zoomed in to seconds. Now, the group that put together this piece of work said that creating their study took about 3 months to produce this graph. They did a replication using modern AI, GPT-4, and it took about 2 days. What happens when understanding text, understanding prose becomes immediate? Another example, this is a representation of an essay I talked about earlier, which is Douglas Engelbart's Augmenting Human Intellect, which is his funding essay that then, was funded and then led to the invention of the personal computer in 1968. This is an essay from 1963. This is a representation of that essay, paragraph by paragraph, through what is called embedding space, semantic space. So we can see a narrative develop through space as it kind of moves through. What does this mean? How do we understand this? We don't know yet, but the engineers aren't looking at this. Do different authors have text that moves at different velocities through semantic space? Do some people move very quickly? Do some people move slowly? Do some people circle back? Would representations like this help us catch politicians lying in real time? We're about to move into an era where we can understand text and manipulate text as easily as we use filters in Photoshop with images. We're not ready for that. We don't know what it means. The engineers aren't going to help us. It's the designers and artists who figure out what the opportunities are. So what do we do when we encounter this kind of technology, this new kind of complexity? Because we don't figure it out by standing in front of whiteboards or covering a wall with Post-it notes. Our intuitions let us down because we've come, at least from a technology perspective, through 20 years of digital, where we have developed certain kind of intuitions about how technology works, and they no longer work. What used to be very, very difficult is now very easy. What used to be easy with these computers, we've spent decades building computers which are very good with certainty, no longer holds true. There are new opportunities, such as working with text like Photoshop or having environmental intelligence that we've barely scratched the surface. And what we need to do is we need to open our imaginations and create investigations and compelling artifacts that tell the engineers what to do, because they won't find their way. The way we do that is by rolling our sleeves up and by working with the material, by creating prototypes, by being playful, by resetting what we do, by being weird, because I truly believe there is no better time to influence the direction of technology than right now. Not since the 1990s have designers and artists had such an opportunity to open the possibilities of the future and influence the way that technology develops, is my opinion. The best approach is by embracing the weird, rolling our sleeves up, getting our hands dirty, and by being playful. I'll finish there.
Thanks so much for having me. I'm very happy to be here, and I'm very grateful to Domus Academy also because we started sort of online discussion on LinkedIn, of all the places, now to speak about these things. What I'm going to do today is to give a series of statements somehow against complexity. And the structure I will have is like, I'm not going to show images, and I'm going to use the images at the very end to somehow recap, because otherwise I'm gonna make a mess. Basically, these statements are more or less extrapolation from my last book, which is called What Design Can Do, which was recently published. So to start with, I would like to give a very tangible, concrete image of complexity, which I didn't come up with, but it was provided by Warren Weaver, one of the people involved with a friend of all the cyberneticians that Georgina mentioned. So to speak about complexity, and specifically disorganized complexity, he asked us to imagine this, and I'm going to read it. A large billiard table with millions of balls rolling over its surface, colliding with one another and with the side rails. So you figure it out that it's a bit like of a big scale of complexity itself. So this is the somehow the level of multiplicity we speak about when we mention complexity. As real life examples of these, Weaver mentioned like two things, like a large telephone exchange with many users involved and a life insurance company. So I find these images of the billiard board very beautiful and straightforward. We all can imagine it, but also to a certain extent, completely unusable, unless you are like a physicist or a mathematician. Very few people actually work at that level of interrelation, and surely not the majority of designers. Hence, this is like why I have a certain skepticism toward the idea of complexity as it is currently used in design. And yet, I became interested in this idea because I started noticing that not complexity, but the very talk of complexity was becoming somehow a cultural practice in itself in the field of design. I wasn't the only one noticing this. For example, Guy Julier, which is a design academic, put it like this: it has become an orthodoxy to talk of the growing complexity of design in our complex world. This idea of growing complexity in our society is also untenable. I'm gonna again like quote someone else. It's like Lee Winslow, who wrote like this kind of virally titled article against design thinking, which is called "Design Thinking is like Syphilis," and it basically asks, what does this claim, the claim of a growing complexity, even means? Complex in what way? Increasingly complex with respect to what metric? I have asked many professional historians this question, and they believe this increasing complexity claim is unsupportable. This kind of skepticism, we find like a foresight, like a sort of anticipation back in like critical theory. For example, Theodor Adorno, great critic of the culture industry, argued, speaking about ideology, that society, wrongly scolded for its complexity, has in fact become too transparent. So I wanted also to put my own kind of example to show why, like how the old world, like the antique world, was already complex in a way. You know that these days you say very often, how many times of a day you think of the Roman Empire? Not many, but in this case, twice. Because there are like two interesting theories about the fall of the Roman Empire that shows like this kind of crazy interrelations about like in the past. Like the first is about lead poison. The fact that apparently, of course, it's a sort of a factor, let's put it like this. So the elites in the Roman Empire would drink wine from cups of lead, and lead is poisonous, so they would somehow go crazy and make like terrible political choices. So you see how like a very complex idea of like how to act in the world on a scale of society could happen. Like the other theory in this sense comes from Marshall McLuhan. And this idea was that the fall of the Roman Empire was due to the shortage of papyrus, I don't know how you pronounce it in English, because basically it prevented communication on such a vast territory. So there was no way to control it. There was no way. You had to wait, like, you had to send people far away. It would take months. Well, it would take months anyway, but like then, you would have like more memory, no, to bring in. So if complexity in this broad sense is not a new phenomenon, and complexity in a narrow sense is to a certain extent difficult to use, why is it so present in conversation and articles? It has to play some sort of other function. And I think that to understand this function, we have to understand how disciplines, included design, work. Of course, we all agree that disciplines are artificial compartments of knowledge. They are somehow strategic boundaries set up, erected in order to examine and hopefully solve a specific problem. An example of a discipline born this way is sociology, that suddenly realizes that there is this new category understood as a problem, which is society. And a lot of people come together to address this problem not in the designer sense, but in like the conceptual sense. Another example of like discipline born this way is cybernetics. A lot of people come together around the idea of feedback loops, homeostasis, and so on. So there is nothing. Yeah, you see, too many things. There is like a sense of disciplines like being arbitrary in defining their own disciplinary problem. But there is like a counter movement, which is like, since like the disciplines are arbitrary, the people work inside, like they push up, they try to extend the boundaries because they say, hey, but this specific part of the boundary is arbitrary, so you have to bring in also this element. And so you have like a sort of inflation of the discipline. This is very evident in design culture, which nowadays you hear very often like the claim that everything is design. So there is like an attempt to bring in more and more issues and to somehow redefine the boundaries of design. But beyond, like, let's say this physiological extension of the boundaries, we have another phenomenon which I find more interesting because it's historically specific, and has to do with the role of the professional in the social world. Already in the 80s, a US philosopher called Donald Schoen spoke of what he called like the proletarianization of the profession. He was saying that basically the profession was, the professional as a figure was somehow losing prestige in front of the public, was losing both reputational return, like image, and economical, financial return. This was why basically like the image, like the idea, the role of the professional was somehow democratizing. A lot of people call, like probably everybody in this room would call themselves nowadays a professional. So there has been like this kind of democratization. And this goes hand in hand with another phenomenon, like a sort of general distrust towards the experts. You see this very clearly if I mention fields like economy. No, it's like you see that when you watch TV, you don't trust very much like the expert because he's an expert, or even, and more scarily, things like virology. So what do professionals do to regain that prestige? They accelerate this process of expansion of the discipline, creating connection in an almost conspiratorial way to the subject of their studies. And here I want to make a nod to Carlo Bramanti, which is a young designer and researcher who is making like a work on conspiratorial design, showing a bit like the similarities that there are like between conspiratorial thinking and design system design, system thinking. And so you will see that there is like a lot of similarity between diagrams, which I will show, of people like Victor Papanek And like, you know, these conspiratorial images that show a connection between like, you know, very different agents active in the world. So, you know, and you know what's the role of this? The role of this is a bit like what happens with cybernetics, what Georgina was saying, that with this kind of discourse, with this cultural practice, you produce a sense of control on the messiness of the world. Everything, to a certain extent, makes sense if you connect the dots. So there is this kind of hypertrophy in this sense. So the provocative statement here is that generally we think of complexity as something difficult, worrying, frustrating, but fundamentally complexity turns out to be a reassuring category. Reassuring to whom? To the professionals who are there to explain it and clarify it, to show it to the public, to say which dots connect to what other. To leave, and here I quote like the book of Georgina, which I took the chance to start reading, the authoritative stain of scientific inquiry. And there is a further paradox here. You remember, I don't know if some of you remember like Game of Thrones. There was like this meme back in the days, like 10 years ago, that was like, it's not that simple, no, with the king that was struggling. So basically, in order to reassure themselves, the professionals tend to increase the visible complexity. So they have to say that it's even more complex than what it is, because like they have a vested interest to, you know, to show their own ability to read the world. And I think this leads to another thing. Sorry, Georgina, I'm going to quote you a lot because like the book was the Airbook bookshop model of system thinking, which tends to involve a lot of graphs and urges to shift your mindset, which we are like both somehow skeptical of. But adding links and relationships means, in my opinion, more often than not, just a way to create more confusion, more noise, more chaos. And this is like the other category that I propose, which is a sort of return of the repressed in design culture, in innovation culture. You never find, you find, while in the papers, you find a lot of talking of complexity, you find very little the word chaos. Because it's, to a certain extent, it's sort of a taboo, because it's really a scary category, because chaos somehow resists any attempt to order. It's just like meaningless. It's like it throws you in a fragmented world of complete disorientation. So it's really a scary world. And I'm not suggesting a way to deal with chaos, but I think like chaos is a generative category for thinking the way we exist in the world. That's why I like a lot of horror fiction, because like while science fiction is really into the complexity mode, like systems, horror is like just surrenders to it. Like think of Lovecraft, think of Ligotti, no? It's like, it's just chaotic. You cannot do anything. You are sort of like eaten by chaos. But so, should we surrender as Lovecraft or Ligotti do? No. Like my takeaway from this is inspired by a philosopher I like really much, which is called Cornelius Castoriadis. Basically, this is the difficult part. So I have to look at it, and this is the conclusion. So be patient with me. So basically, he suggests, Cornelius Castoriadis, a sort of compromise between like the activity which is fragmented, situated, connected to what you can, the small space that you can control, and the vision, the project, the long-term image, because it's what we do in all life. But to do this, we don't need to have like this distant picture of like complete totality. And yet, totality is there. And that's the tragic part, in the sense that we encounter the world as a totality against us. We are born in a world with buildings that will survive us. So that's the tragic aspect of this, that, you know, as he puts it, is very beautiful. The world doesn't give itself as totality, because we can only engage with like little parts of it, but subtracts itself as totality, because it's a thing so big that, you know, escapes us. So the beautiful idea here is very similar to what Allison was saying, because like also Castoriadis, like a lot of feminist epistemology, basically says this, that the situatedness, the fact that we only have that point of view, that little narrow point of view, it's not a bug, it's a feature, no, as programmers would say. So basically, praxis, which is like the category that Castoriadis used to speak about this, means that you are, when you are acting, you are locating, to go back to the beginning, within the billiard table. Inside, you are one of the balls. And your only hope to a certain extent is not to fall in one of the pockets too soon. Thank you.
All right, last up. Thank you for being here. I'm Georgina Voss. I am the author of Systems Ultra, Making Sense of Technology in a Complex World. I am variously an artist and a writer and an educator who's worked in art and design schools for the better part of the past 15 years. I have run several studios, and way before all of that, which is important, I didn't start out in art and design. I started out in industrial economics and anthropology and science policy. So this kind of multi-layered, chaotic way of engaging with the world has been quite useful for coming to the point where I am now. A lot of the work that I've been doing for the past decade has focused on what are often quite boring industrial systems of airspace and supply chains and financial platforms and other complex, what we might call complex technologies. But the way that I've been working through them, both through studio work and practice-based work, and maybe most of all teaching, has been trying to find ways through them that are not maybe the classic engineering mode. And that was kind of, I guess, where I'm here today. A lot of ways of thinking about them do require, or not require, nothing requires anything, but you can have a lot of fun and get very frustrated at trying to dig into them in different ways. A quick note to say that before our panel, I also gave a talk at the end of the day here. So I didn't really want to repeat anything that I said there, and instead kind of pick up on three kind of hanging things that I'd kind of left hanging in that talk, which I think, by the nature of this, speak to a lot of what we've been talking about so far. So let's see if this works. Yeah, all right. This is an airport. If I've got my pictures right, this is Heathrow. So I wanted to start with this. So this is the very kind of structural way of thinking about this, I think, which is to build on what everyone says, and particularly what Silvio has said, this existential angst in a way around complexity or chaos in design of what is it, what's it want, where is it going, where is the professionalization of it. Airports are really interesting. Airports have a history that obviously, we've had airfields, we've had zeppelins, but then we get, in the 1910s, 1920s, we start to get airplanes. And they start to be made at a point where oftentimes you'll just have a field big enough probably for a plane to land in. Then you start to get a point where someone is there bringing in the plane, like waving a big flag. Then the person on the grass is showing lights. Then there's more than one plane. And then there are different places where the planes fly from and to, and then the government gets involved, and then the wars take place, and then the government gets involved again. So airports themselves have become, particularly after the 1940s, have become much more structured places. And kind of, I guess, from my early life more in economics and anthropology, one of the things that my colleagues there looked at was this idea of complex projects, which is what airports are. They are one-off. Heathrow is Heathrow, Gatwick is Gatwick, they are large scale, those are very big planes, and they comprise many different interlocking components and subsystems which are all brought together in service of a common good, which is have a place where flying vessels can take off and land safely in a way that adheres with borders, if there are borders. And this thing kind of pushes back an airport, as anyone who has ever spent time in or going through an airport know, really pushes back at the idea of technology working. They are places where it's not sleek. It's not this kind of like super sleek entanglement of like cars and machine and code and people, you know. They are big and they are messy. And these kind of complex projects are often characterized by changing conditions and uncertainty. The management scholars who work on who theorize complex projects have called them lumpy. So if you're an engineer involved in building an airport, you're building a lumpy project. They are similar to other things, but not in a way that's obvious. So it's kind of this complexity that makes them, that has that kind of resonance between them. And it's not only between airports. Other things that are like airports are nuclear power plants or large-scale science experiments. And what management scholars talk about is it requires its architects to have what they describe as a disciplined flexibility. So some things get fixed in place, others are open to deal with the unexpected. And this is again where more classic system theorists like Donella Meadows talk about systems are surprising. That kind of things happen in ways that you wouldn't necessarily expect. So this part has always been interesting to me, of like, not that it's easy to build an airport, it absolutely is not, but it's this thing where there is kind of, from the engineering and the project management literature, like fairly defined rubrics around what might need to do to build something this complex. Which is not to say that anyone actually pays attention to management scholars, because, you know, complex projects, obviously, particularly government IT projects, run over time, run over money, and never delivered, ended up mired in corruption. But there is kind of a structure for thinking about it. But this also kind of fits in, I think, and the ball is returning to earth, because I'm now going to talk about non-places again, but with airports, not with biomes. There's also the theorizing around airports in the manner that Matt Webb talks about. He says they are non-places for the passenger. He talks about the businessman who is traveling, say, through Paris, through Charles de Gaulle, he doesn't experience the airport. He runs to it. He has his passport. He goes through border control. He maybe has a moment to catch his breath in duty free and buy some gin. And then he runs to his plane. He has a magazine. It takes off. He doesn't experience anything. It's just the airport is the non-place for this. And this, with all respect, and drawing on many other people's work, is not true. It's like airports are places. Airports are places because they exert power through their complexities. They exert power in terms of who is allowed to fly, in terms of who is surveilled. If you are traveling, as Simone Brown theorizes it, if you are traveling whilst Black, then you very much experience what the surveillance microculture is of the airport, of where you might be pulled over, or how your body might be seen as suspicious or threatening in some way. Even the act of going through the airport, which Auger describes as kind of like seamless, is not. If you've been through airport security, I'm not going to raise my hands above my head, but if you've been in kind of one of the scanners that they're there, those things are also programmed with, say, a very strict gender binary in place that will not read certain body types. If you are traveling with a disability prosthesis, if you're traveling with certain types of if you have a certain type of hair, this may also be seen as a threat in some way. But all of this is kind of both layered on within the design of the airport to be somewhere very bland indeed, somewhere where there is a distraction of duty free, somewhere where the traveler is to an extent numbed into not questioning what is happening, or is not in a position of the power dynamic to do so. And the passenger who is able to pass seamlessly is the one who exists in a different realm of society, a different realm of privilege. So that part of where complexity acts, I think, was the kind of thing I was grasping for here, of how, where do you feel it? Are you intended to exist within this structure, or are you not? And if you're not, that structure will make damn sure that you are aware of that part. The second part, which is broadly unrelated, but will also, I think, respond to Silvio and to what I said earlier about graphs. Oh no, this is not the one, but we'll go back to this. This in fact responds to this, again, the earlier talk of biomes from Allison. So this is a project called Deep Swamp by Tiga Brain, who I also cited earlier. Tiga is amazing. If you just want to zone out for a little and look her up. Her work is phenomenal. She's an artist, an engineer and educator based in New York. And a lot of the work she's done recently is around the idea of systems and environmental systems, particularly kind of how kind of a systemic structure or way or mode of thinking is applied to the environment. So just to tell you a little bit more about what we're looking at here is some plants in a large glass tank. And this is one of three such pieces. So Deep Swamp is a triptych of semi-inundated environments that gather together wetland life forms and artificially intelligent software agents. The agents are called Nicholas, Hans, and Harrison. So these AI agents patiently watch their swampy territories and modify the conditions in them. Every few minutes, they adjust the light, water flow, fog, and nutrients to try and engineer their environments for different goals. Harrison aims for a natural-looking wetland. Hans is trying to produce a work of art, and Nicholas simply wants attention. So this is kind of a little similar to those plants that sold themselves on eBay if they weren't getting watered enough. Using a deep learning approach, each software has learned what their goal might look like by passing thousands of tagged and categorized images downloaded from online collections. Over and over, they try new combinations of settings, photograph themselves, and then choose permeations that bring them closer to their programmatic desires. So the context for this is, well, it's environmental destruction and environmental degradation. As Tiga says, as territories flood and melt, dehydrate and erode, paradigms of environmental protection and conservation give way to those of management, engineering, and strategic intervention. In this sense, conserving wilderness has become more about maintaining autonomous ecological processes rather than the preservation of historic conditions. And if a new wilderness is the absence of explicit human intervention, what would it mean to have autonomous computational systems sustain wild places? And I mean, I fangirl her work enormously, and I love this piece because it pushes. She is the author of an incredible essay called "The Environment is Not a System," which traces back the origin of the word ecosystem again into the kind of more cybernetic way of being able to map and control, and then pushes that out but through her artworks into what would this look like if. And I think coming back to some of the kind of the points we'd made earlier, I really like it as something which is not an engineering solution, but which is basically about three different autonomous agents, you know, one of whom just wants some attention, and why you're not paying attention to it. So yeah, I love this piece of work. I think it's really smart, and it kind of, I think wanted to talk about it in terms of where the systemic framework fits in different ways through it. And if I've got my slides right, there'll be one more. Yes, all right. Okay, we're finishing with the best one. This is for Silvio. This is the graph. Yeah, that's right. I will say at this point that I have been for a very long time, first on Twitter, and I think now on Mastodon, a member of it's not even an online group, it's like a thread where a bunch of us share deranged diagrams that we find, I think loosely called Diagram Club. It's been going for years. At the point where we thought Twitter was going to die, I spent like a morning in a coffee shop frantically screen grabbing every single graph, and I now have like a lot of weird graphs in my hard drive. This is one of them, and I love it. So this is kind of partly the response of kind of like, what is mappable, what is a graph, where does scientific authority bear on a graph? And I love this because it's like the graph, it's the Uber graph. This is from a paper that attempts to, let's see how they put it. The physicists describe it as presenting an overview of the thermal history of the universe and the sequence of objects, such as protons, planets, and galaxies that condensed out of it. So they describe this graph as like plotting the density and temperature of the universe as a function of time, and the masses and sizes of all objects in the universe. So this is it. This is the graph. Everything in the universe is here. I love it because the physicists describe it in like quite a dry, well, not dry if you're a physicist, but it's a kind of like, it's a very specific physicsy way. They say that they ask, how can we interpret the intersection of the smallest possible objects of Planck mass black holes? Does their Planck density and Planck temperature make them good candidates for the initial conditions of the universe? Our plot of all objects also seems to suggest the universe is a black hole. So like, think on that one tonight, a bit later, as you go to bed. And they say, we explain how this depends on the likely assumption that our universe is surrounded by zero density Minkowski space. But it's great that like this is just one of those great graphs where you have that bit where it talks about things being forbidden by gravity, where forbidden is due to quantum uncertainty, where objects cannot be denser than black holes or are so small that it blurs the very nature of what it means to be a singular object. And it's great. It feels like it kind of encapsulates everything that we've talked about graphs of something that's trying to do everything. And I also love the color scheme. It's just really plain. Like you could really get some good colors here, but like some choices were made into this. I'm going to leave that one there. I'm not sure this is a good conclusion for like my 3 separate bits, but it's a great graph. And I thought that might be a nice thing to have while we chat. So thank you.